For today's lesson, our focus standard continues to be from grade 8, Functions, Standard A, Define, Evaluate, and Compare Functions. Our topic today still comes from Mathematical Models, Defining Functions in Graph Form. Our essential question is, how do we recognize functions in graph form? Please take a moment to set up your header, including today's date, the question column, and the note column, and then let's continue to look into functions in graph form. So we want to make sure that we are understanding this word function that we keep using in class. And so by definition, function is a relationship that has exactly one output for every input. The output values are always represented by y on the coordinate plane, and the input values are always represented by x. So today we're going to look at graphs in particular and trying to find graphs that have exactly one y value for every x value. Before we dive into the graphs, though, I want to show you this organizer that I've kind of set up to kind of help clarify our thinking. So we've been talking about mathematical relationships, and everything we've been talking about so far has been in this green area. We've been talking about functions, and everything we've looked at is a function. And then we've been subcategorizing those as linear and nonlinear. So this week we're starting to expand that and say, well, there are these other relationships out there that are non-functions. They also happen to be able to categorize into linear and nonlinear as well, which we won't necessarily dive into too much, but you'll be able to tell. But we're starting to say, okay, if there are things such as functions, what does non-functions look like? And today we're doing that in graph form. So there's two graphs that I want to start to look at. So here we have the equation y equals 3. You can see it has a y-intercept of 3. It crosses the y-axis at 3, but it has no slope. And so that is why you just see y equals 3. And this would be the resulting graph of that equation. Over here, we have the equation x equals -5. You'll notice in this equation there's no y value. And interestingly enough, the graph that comes out of that is a vertical line. It has an x-intercept, and the x-intercept is -5. But anytime we put -5 into this relationship here on this graph, we're going to get any possible y value. If I put -5 in, I could get +10 as a y value. I could get +8, I could get +3, I could get +1, I could get 0. All of these y values are possible when I put x in. Contrastly, over here on y equals 3, that is not the case. If I put -10 in for x, then y is 3. That's just one output when I put an input in for x. If I put -5 in for x and I follow that up, it only hits my line once. Happens to also be 3. If I put 0 in for x, I'm going to get 3. Still one output for each input. And that would continue. And so we would say that the graph of y equals 3 is a function, but the graph of x equals -5 is not a function. And this is an important distinction. These two are important because this graph, this vertical line, is actually going to help us to test any graph to decide if it's a function or not. We call this the vertical line test. So I've just made another copy of this vertical line. And the way this works is that, and I'm actually going to start over here. If we put a vertical line representing an x value, so we could say that this is x equals -5 again, because I just copied it off of here. Notice it only hits my graph once. So this means for this input on x, there's only one output. Move it over here. When I put this value in for x, let's say it's -3, the only output, the only y value crosses once, and that's 3. so on and so forth, and we just talked about this, but wherever I put this line, doesn't matter, it's only going to cross the graph once. So as long as it only crosses the graph once, it matches our definition, exactly one output for every input. Over here though, on x equals -5, if we put -5 in for x, notice it hits everywhere. They are the exact same line. There's lots of y values. Any y value would be possible. So therefore, when we're looking at graphs, we use a vertical line test to identify functions and non-functions. Let's take a look at a few now. Here's our first graph. It doesn't necessarily matter what the equation is, but I'm going to use the same vertical line test. I'm going to see if I move this to right here, whatever this x value is, and I can't even quite get there. But there's a point right there where maybe it only hits once. Hard to say. But if I look at an x value closer and maybe say x is -1, this is a problem because it crosses right here and it crosses right here. So because on this x value, which let's say it's -1, there are two possible y values. This one up here that's positive and this one down here that's negative. That's more than one output. So we would say that this graph is not a function. Let's take a look at another one. Here we have a nonlinear relationship. It's got another nonlinear relationship. It has a curve to it. Now we're going to give it the vertical line test. Is there anywhere on this graph that if I put a vertical line, it crosses our blue relationship more than once? The arrows don't really count. We're looking at these thin lines, so I would say no. There's anywhere that I put this, it's only crossing this graph once. So we would say the graph of this function is a function. Take a look at the last two and decide for yourself. Do you think it's a function or non-function? What do you think? Well, let's give it the vertical line test. If I put, looks like it just crosses once, only crosses once, all the way through, it passes the vertical line test. It only crosses the line one time. So this nonlinear relationship is a function. What do you think of the last one, of this circle? If we give it the vertical line test, what happens? Well, here on the edges we could say maybe it crosses just once if we could get it right on the very tip. But right here, and really anywhere in between the two edges, it becomes a problem because for this x value, let's say this is x equals 2, it could be this y value, that's positive, or it could be this y value, that's negative. That's two possible output values for the one input value. So we can make a similar, circle that up here. So we can see here that it crosses this input value twice. And so it does not pass the vertical line test, and therefore the graph of this relationship, which is a circle, is not a function. So that's going to conclude our lesson for today on recognizing functions in their graph form. Please go ahead and make sure that your notes are complete and come ready to practice this more in class.